Hey, you're the one that's all banned. I was trying to you're like, hey, I'm not going to quit at that on the function. Did you have to audition? But I didn't want to put my mind in it because I was going to go.
Oh, that's funny.
I kind of saw that coming.
I think last year, I think he got technical here at this tournament. I don't think he got ejected, but.
Wait, what happened when he got ejected? Well, you can't stand up after second technical.
After your first. First.
Wait, so he gave him a warning, then a technical, and then he got ejected?
And then you got a second technical, which gets you ejected from the game.
What are you getting technical for?
Can't Galva's girls JV coach. Arguing with the ref, basically.
Oh, Jordan just touched the ball. I thought
They always.
that was funny because Jordan went up, and then number 35 was like,
So, the coach was, yeah.
Yeah, he didn't call it, and then he just starts running. He's like, no, it didn't hurt.
Is that the taller ref? He was the one that ejected the. I could tell, like, he was tired. He was done. By the end of the day, he was like, "You're out of here."
It held everything. Yeah. Compared to like.
Yeah.
It's like Saturday is only.
Okay. So these are still going to be quadratics, which means we have what kind of exponent? What's the biggest exponent that we have? 2, x squared. We're going to have some sort of x squared. So remember way back to your elementary days, factoring is the process of finding what multiplies to a given expression. So if we use regular numbers and we just say factor the number 10, what multiplies to 10? 2 and 5. So we say the factors are 2 and 5. Okay? So if we want to factor the number 8, that's 4 and 2, but the 4 goes into 2's, right? So how many 2's do we have? So it's going to be 2 cubed, or we have its factors are 2. So factoring, that's the other thing, is we want to go all the way down until we have prime numbers. Okay, prime factors. So we want to use prime factors. Don't leave it as 4 and 2 because 4 is not a prime number. Remember what a prime number is. Okay. So prime is when the only factors of an expression is 1 and itself. Now, of course, we're not just using the numbers today. We're going to expand this into expressions. What's the first prime number? 1 is not considered the first prime number because it's what they call a special case, because 1 is itself.
oh, so then 2.
So the number 2 is considered the first prime number. Okay, so 1 is not considered a prime number, it's a special case. What's the only even prime number? 2. Okay, what are we asking?
What does that say? Because it means R.
Oh.
I don't know, but it.
Okay, prime? What did I miss right?
I don't know. What is it? Like a B open. What is it?
Is 1 in itself. So when the only factors of an expression is R, you're saying that should be R? Pretty.
I thought
Okay.
it was a 1 and a 3.
Oh. 13, yeah, it would be confusing. Okay. So, R1 in itself is 1 in itself. You can debate that later if you want to. Or maybe you know the answer. You can ask Mr. Guru. Okay. So, what two things can multiply to, let's say we have 5x plus 10. So we have an expression. So if I'm given 5x plus 10, and I want to write it as something times something else, is there something common between a 5x and a 10? Is there a factor between those two that is the same? 5. Okay. So what we say is the greatest common factor is 5. So since factoring is basically the reverse of multiplication, what operation is the reverse of multiplication? Division. So we're going to divide by 5. So we divide everything by 5, and we get 5 out in front. So we're going to put the 5 out in front, and we're going to put what's left inside. So we get 5 times x plus 2. So this is going to be the first step. Whenever you factor, you're going to look for what we call a greatest common factor. Look for a GCF, greatest common factor. Okay. You see how this can go both directions? If I distribute the 5, if I multiply the 5 through here, do I get 5x plus 10? So factoring is just the reverse distribution basically. Okay. What about x squared plus 3x? Three is already prime, I agree. But what's the same in both an x squared and a 3x? X, a 1x. Okay, 1 is prime. You can't take any other number out, but you have to flip it that variables represent numbers. Okay, variables represent factors. So if this is x squared, there's 2 x's here. Okay, there's x times x. And if this is 3x, there's another x here. So we say our GCF in this case is 1x, or you can just put x. So the other words I use here is I say you have to pull things out to the front. Pull them out to the front. And when you pull them, you're basically dividing things out. So here, if our greatest common factor is x, I'm going to divide both sides by x. The x goes in front of the parenthesis. So that first one, I had x squared. I divided by x. So x squared, I'm taking one of the x's away. How many am I left with? 1. There's 2 there. I'm taking one of the away. So that leaves me with 1 more left there. And then 3x, taking x away, you're left with 3. So it would be x times x plus 3. That would be the factors. So let's do 12x squared minus 4x. 12x squared minus 4x. No. 4 and then. So look at the numbers. Look at the variables. So look at both parts now. I'm putting both parts together here. 4 and then x. So here, greatest common factor is going to be 4x. 4x goes in front, do a parenthesis. So 12x squared divided by 4x, 12 divided by 4 is 3. X squared divided by x is x. So is it just 4x times 3x because those cancel off?
No, because you have to a negative.
Minus 1. 1. Because they are identical. When you divide something by itself, you equal 1. 5 divided by 5 is 1. So 4x divided by 4x is 1. So that would be the answer right there. Okay. Eventually, we're going to tie this process into finding the zeros of the quadratics, which is just one more little step. But today, we're just going to practice with the quadratic stuff. Okay. Let me get some. We're going to move into the actual trinomials. Take 2x plus 3, and I want you to multiply that with x plus 4. So FOIL that out. Remember the FOIL process? Double distribution. Let me, hang on, yeah. Is that this year? Surely we've gone over that.
Yeah, we did.
Yeah. Last year also. Yeah. Last year also, probably. Now, FOIL is what I call a double distribution. You have a 2x, you have to take 2x times x plus 4. Okay, so that's the first and the outside, you see that? 2x times x plus 4 plus 3 times x plus 4. So inside and last. So it's a double distribution. So 2x times x (2x times 4) plus 3 times x plus 3 times 4. Is that okay? We're not done yet. Yep, we're not done yet. These go together, you get 2x squared plus 11x plus 12. Can I combine the 2x squared and the 11x? No. Okay. Well, it's here. It's just going to be in reverse. Okay. And I know you did a little bit of factoring last year. We're going to actually jump actually to the end of what the book does with the factoring. The book starts little and it tries to give you lots of different ways to do different types of problems. The method I'm going to show you is going to always work. But there are several shortcuts. Okay? And if as we go through this, hopefully you start figuring out some shortcuts once you see some patterns. But this method that I use and I'm going to teach you is going to always work for any sort of trinomial. Okay, so that's why I start with this, because it's always an old reliable one. So we're going to factor. We're going to start with what our just answer was, 2x squared plus 11x plus 12. And the process that I have here is called splitting the middle.